morning, everybody. Hope you are all well. Today I shall stitch squares and square root. First, definition of square. The square of a number is that number raised to the power 2. That is, the square of a number is obtained by multiplying it by itself. For example, a into a square. Here, raised power 2. Then the perfect square number. A natural number is a perfect square if it is the square of some natural number. For example, 25 equal to 5 square. So natural number is 5. So 25 is a perfect square. Then the properties of perfect square number. A number ending in 2, 3, 7 or 8 is never a perfect square. Then I am clarifying it. Square equal to 0, 1 square equal to 1, 2 square equal to 4, 3 square equal to 9, 4 square equal to 16, 5 square equal to 25, 6 square equal to 36, 7 square equal to 49, 8 square equal to 64, 9 square equal to 81 and 10 square equal to 100. Here in this number there is no 2, there is no 3, there is no 7, there is no 8. So the property is the number ending in 2, 3, 7, 8 can never be a perfect square number. Second property is a number ending in an odd number, property number 2. A number example is 160, 4,000, here number of zeros is 1, number of zeros is 3, number of zeros is 5, so this number cannot be a perfect square number. For example, 10 square. This is 100 square. This is 4 zeros. So if there is 2 zeros or 4 zeros or 6 zeros, then that number is a perfect square. If number of zeros is odd number, then the number cannot be a perfect square. Second property is this. Third property, if a number divided by 3 leaves leaves a remainder to then it is not perfect square. So to check whether a number is perfect square or not, then you may divide by 2, and if you get remainder 2, then that number cannot be a perfect square number. For example, 178, 360, 635, 98, 122, etc. Here, if we divide 122 by 3, then 12, then 2, then 0. Here, remainder is 2. So, third property states that if a number when divided by 3, here we have divided 122 by 3, we are getting 2 as a remainder, then this number is not a perfect square number. 123 to 6, 1. Then 61 is a prime number, so 122 is not a perfect square number. Fourth property is if a number when GI is divided by 4 leaves a remainder or 3, then it is not perfect square. For example, say 67 or 146, 1002. So these numbers are not perfect square numbers, because if we divided these numbers by 4, then we may get either 2 or 3 as a remainder. So first take any number, say 146 divided by 4. Borrow plate, this is 2, this is 6, that's 24. So you are getting 2 as a remainder. So this 146 never be perfect square number. So let us check whether 146 is perfect square number or not. So 73, 2 and 3 is the factors. 73 is a prime number. So 146 is not a perfect square number. Property number 5. square of an even number, the square of an even number is always even. The square of an even number is always even. For example, 2 square is equal to 4. 6 square, 4 square is equal to 16. So 6, 4, these are the even numbers. So property number 5, the square of an even number is always even number. Property number 6, the square of an odd number, square of an odd number is always odd. For example, 3. 3 is an odd number, so 3 square this is equal to 9. 9 is also a odd number. 5. 5 square this is equal to 25. 25 is also a odd number. 7 this is equal to 7 is a odd number. Then 49 is also a odd number. So the property 6 is the square of an odd number is always odd. So we are getting the odd number. Property number 7. The square of a proper fraction is smaller than the fraction. So 2 by 3 is a proper fraction. Is a proper fraction. So square of 2 by 3, that is square of proper fraction, is equal to 4 by 9. 4 by 9 less than 2 by 3. Since 4 into 3 less than 9 into 2. So the square of a proper fraction is smaller than the fraction. Here fraction is 2 by 3. The square of proper fraction 4 by 9. 4 by 9 is always less than the fraction. Fraction is 2 by 3. Property number 8. For every natural number n, for every natural number n, we have n plus 1 whole square minus n square. This is equal to for example, 36 square minus 35 square. So this result is 10 plus 1. Here A is 65, 35, and then 36 equal to n plus 1. So by this property, n plus 1 plus n. So this is 36 plus 35. This is equal to 71. In this way, you may get the result. Or this is another example is 89 whole square equal minus 88 whole square. Here, how we can get the result quickly? Here the result is 89 plus 88. This is equal to 177. Actually, a square minus b square, there is a formula a plus b into a minus b. Here 89 whole square minus 18 whole square, this is equal to 89 minus 88 divided by 88. 89 plus 88. 89 minus 88, this is 1. 89 plus 88. So for this reason, if there is two numbers and the difference of the two numbers is, here n is 35 and n plus 1 is previous number, then you will get the result by adding these two numbers. Property number 9. For every natural number, we have sum of first in natural number, NATUR, a natural number equal to n square. For example, first natural number 1 plus 3. Here number of terms is 2. Then this is equal to 2 square. This is equal to 4. Here 1 plus 3 plus 5 plus 7 plus 9. Here number of terms is 1, 2, 3, 4, 5. This is equal to 5 square. This is equal to 25. If you add these numbers, first not, but compare तरफ से इधर 4, 5, 9, 9, 7, 16, 16, 9. So sum of the first in natural number is always n square. Means number of terms square. Property number 10. This is very important property. Pythagorean equivalence. For three natural numbers, this square equal to this square. For example, 8, 15, 17. Pythagorean triplets is 15 square, 80 square, which is equal to 70 square. Means 18 square plus 15 square, this is equal to 17 square. This is equal to 64 plus 225. This is equal to 17 square. Another example is 2, 3, 5. This is equal to, no, this is not Pythagorean triplets, because here 2 square plus 3 square, this is equal to 4 plus 9. This is equal to 30, not equal to 25 square. So 2, 3, 5 are not Pythagorean triplets. Another example is 10, 24 and 26. Here, always larger number is the hypotenuse of the Pythagorean triplets. Another two numbers, one is base, another is altitude. So this is equal to 10 plus 24. This is 26. So you may write 10 square plus 24 square equal to 26 square. Always keep the three numbers forms Pythagorean triplets. And you solve the exercise 3. Exercise 3b, first problem. Give reason to show that none of the numbers given below is not perfect square number. For example, some number 5, 3, 6, 0. How you can check whether this number are perfect square number or not? Property number 3 and 4. If a number when divided by 3 leaves remainder 2. So first check 360 by 3. This is not the property. Here at last number of zeros is 1. So number of zeros is 1 means the property is a number ending in an odd number of zeros never be perfect square. Here number of zeros is 1. So by this property number 2, this number is not a perfect square number. Another example is 64. odd number, then this number is not a perfect square number. So sum number 7, 2, 5. Here number of zeros is odd number, that is 5 zeros. So the number is not a perfect square number by the property of 2. A number ending in an odd number of zeros is never a perfect square. Problem number 2. Which of the following are square of even numbers? Say 196. How you will check? Here the first digit is odd number, so this is the squares of an even number. 2, 4, 4, 1. Here number is odd number, so this is the square of an odd number. The property number 6, the square of an odd number is always odd. Here 4, 4, 1, this is equal to 21 square. 21 is always a odd number, so 4, 4, 1 is the square of an odd number. 6 to 5. Here 6 to 5 is an odd number, so this is the square of an odd number. This is 25. 25 is an odd number, so 625 is the square of an odd number. Solve the sum, all sums in exercise 3b.